are a type of quadratic or polynomial function. Because a polynomial function is a sum of different monomials. Is a monomial or sum of them. So if we have just a number, such as f of x equals negative 14, that would be considered the constant function because the degree is 0, constant function, just a number. If the degree is 1, our 5 to the x, or 5x, not 5 to the x, but 5x is the variable with the biggest exponent. The degree is 1, therefore it's a linear function. If the degree is 2, we consider it to be a quadratic. And that's what we did in Focus Chapter 3 on. Really, Chapters 2 and 3 were both over quadratics. If the degree is 3, so we have an x cubed term, it is going to be considered a cubic. And if the degree is 4, it's going to be considered a quartic. Really, we do have functions with degrees of 5, 6, 7, 8 going on, but these are the main 4 or 5 that we have that have a specific name to them. Questions on those so far? Now, standard form. When writing a polynomial, in order of decreasing power from highest to lowest is considered to be in standard form. When the variable with the biggest exponent is first, and then decreasing as we write it out from left to right, is considered to be written in standard form. If the leading coefficient, or what our leading coefficient is, it's the number in front of the variable with the biggest exponent. So the number in front of the variable with the biggest exponent is going to be the leading coefficient. Really, any number in front of a variable is a coefficient. The one in front of the variable with the biggest exponent is considered to be the leading coefficient. We understand the difference between those two. All right. Now, is it a polynomial function? Take that away so now that this function's a little better. There's different ways we could approach it. I think it's better to look at what it does not have. As long as it does not have the following properties, or really, it satisfies these, we know that it is a polynomial function. The first, exponents aren't negative, specifically attached to variables. Exponents attached to the variables aren't negative. That means we can't have x to the negative 2. We're mainly going to focus on our variables being x, but I can't have x to the negative 2, x to the negative 3. The exponent attached to a variable cannot be negative. If it is, it's not a polynomial function. Our second one, exponents aren't fractions attached to variables. We can't have x to the 1/2, x to the 1/4, x to the 1/3, x to the 7/9. Cannot have that. 2 to the 7/9, that's fine. Variables cannot have fractional exponents. Our third one, exponents aren't variables. This doesn't matter if it's a number or a variable. I can't have 2 to the x, and we can't have y to the x. We cannot have a variable and an exponent, be it a number as a base or a variable as a base. So we good with the first three. The next one, variables aren't inside of a radical. We can't have the square root of x. We can't have the cubed root of x. We cannot have a variable inside of a radical. So square roots, cubed roots, fourth roots, all of those are just different types of radicals. Variables aren't multiplied together. Specifically, we're talking about two different variables. X cubed really is x being multiplied by itself 3 times, but we're saying that two different variables, or more than two variables, cannot be multiplied together and it still be considered a polynomial expression or function. And lastly, variables can't be in the bottom of a fraction. I can't have 1 over x. Because if any of these show up, negative exponents attached to variables, fractional exponents attached to variables, exponent variables, be it have a base of a number or variable, does not work. We can't have variables inside of radicals. Excuse me, we can't have two variables being multiplied together. And variables cannot be in the bottom of a fraction. If we have any of this here, we cannot say that it is a, well, it's not a polynomial function. It's not that we can't say, it's just not a polynomial function. Questions on this here? So let's look at A. Negative 2x cubed plus 5x plus 8. First, we want to determine if it is a polynomial function. If it is, we want to state, 1, write it in standard form. 2, state the degree, type, and leading coefficient. If it's not, we're just going to say it's not. So if we look at this here, negative 2x cubed plus 5x plus 8, do we have any negative exponents attached to variables? No. Do we have exponents attached to variables that are fractions? No. Do we have any exponents that are variables? No. Do we have any variables inside of radicals? No. Do we have two different variables being multiplied together? Nope. Do we have any variables in the bottom of a fraction? Nope. So can we say this is a polynomial function? Yes. Now, if we want to write it in standard form, we want the variable with the biggest exponent to go first, which in our case is what? Negative 2x to the third. So x to the third, our x cubed would be our first term, our first monomial. Then we would want our x squared term. Is there an x squared term? No, so we don't list it. Then our next term would be our x to the first, our x term, so 5x, and then our constant term plus 8. Really, it is already written in standard form. So we really didn't have to do anything to it, but it will, especially on the homework, I do want you to rewrite it in standard form. What would the degree be? 3. Yeah. X to the third, because we look for the variable with the biggest exponent, whatever that exponent is the degree. So the degree is 3. Now the type. Since the degree is 3, the type would be cubic. Because if it's a degree 3, it's a cubic. If it's a cubic, it's a degree 3. One implies the other. Questions on degree or type before we look at leading coefficient? So I abbreviate leading coefficient as LC, but what would the leading coefficient of this be? Negative 2, because the leading coefficient is the number in front of the variable with the biggest exponent. Because 5 is actually a coefficient, it's just not the leading coefficient. Questions on A? We look ready for the next one. All right. C. H of x equals negative x squared plus 7x to the negative first plus 4x. Can we say this is a polynomial expression or polynomial function? No, why not? There's a negative exponent attached to a variable. X to the negative first. We don't have to necessarily identify what it is, but this would actually be considered a rational function. Because the only way to make that exponent positive, because we have to have it positive, would be moving it from the top of the fraction to the bottom. Because to make an exponent positive, we've got to move it from the top of the fraction to the bottom, telling us really that that middle expression is 7 over x. Fractional expression. We don't have to do that. You don't have to write that, but I'm just pointing out this is why it's not a polynomial. Because this function would be considered a rational function. Questions on A or C? Let's look at B. G of x equals negative 0.8 x to the third plus square root of 2 times x to the fourth minus 12. So let's go through our steps. Are there any negative exponents attached to variables? No. Are there any fractional exponents attached to variables? No. Do we have variables in the exponent? No. Do we have variables inside of radicals? No, it looks like we might, the square root of 2 times x to the fourth, but because that radical, that bar is not extended out over x to the fourth, it's not to be included inside the radical. So it's really square root of 2 times x to the fourth. The x to the fourth is outside of that radical, so we're fine there. Do we have two different variables being multiplied together? No, we don't have an x times y. We're good there. And lastly, do we have variables in the bottom of a fraction? Nope. So that means it is a polynomial function. Is it written in standard form? No, our x to the fourth term has to go first. So we'd have square root of 2 x to the fourth first. Our x to the fourth term would go first. It's the variable with the biggest exponent. Then our x to the third term would go second, negative 0.8 x cubed. Our next term would be our x squared term. But we don't have one here, so we're not going to list the next squared term. Our next term would be x to the first, or our x term. Again, we don't have an x term. And the last term is our constant. So square root of 2 times x to the fourth minus 0.8 x cubed minus 12. What is our degree? 4. And it would be, its type is quartic. It's tempting to say quadratic, but quadratic is degree 2. Quartic is degree 4. And the leading coefficient would be square root of 2. Questions on this here? We ready for D? Yes? All right, problem number D. We can say this is a polynomial expression. Yes? Why not? There's a variable in the exponent, so this is not a polynomial. We would actually consider this to be an exponential. When we have variables in the exponents, they would be considered exponential functions. Questions on A through D? I'd say probably we look at 2 more, and I think we feel pretty good with these here, yes? Let's look at number 1. F of x equals 7 minus 1.6x squared minus 5x. Can we say this is a polynomial function? Yes. Variables do not have negative fractional or variable exponents, and we don't have any numbers with variable exponents. We don't have a variable inside of a radical. Actually, there are no radicals that show up at all. We don't have 2 different variables being multiplied together, and we don't have a variable in the bottom of the fraction. So yes. we can say this is a polynomial function. So since it is a polynomial function, first we need to make sure it's written in standard form. Is it? No, our negative 1.6x squared should be first. Then our next term should be negative 5x, and lastly, positive 7, so plus 7. What would our degree be? 2. Type. Leading coefficient. Negative 1.6. And that's it. Questions on number 1? How about number 2? Not possible. Why is it not possible? Attached to a variable. Yep. So this is not a polynomial. Not a polynomial. That's it. We don't have to state degree, type, leading coefficient, or make sure it's in standard form if it's not a polynomial. We good with these here? Are you ready for the next type of problem? You sure? Right. Evaluate f of x equals 2x to the fourth minus 8x squared plus 5x minus 7 when x is 3. All this is saying is take this function and plug 3 in. This is also the same as saying f of evaluate the following function for f of 3. Really all we're doing is replacing every x in this function with 3. So we have 2 times 3 to the fourth minus 8 times 3 squared plus 5 times 3 minus 7. And really at this point here, I'd grab that calculator and stick it in. I'd plug the whole thing into the calculator and let it do it for you, especially on the ACT. Because if we did this by hand, 3 to the fourth is going to be 81. 3 squared is 9. Now I'm going to simplify 5 times 3, which is 15 minus 7. Now we can do our multiplication. 2 times 81 is going to be 162. 8 times 9 is 72. 15 minus 7 is going to be 8. Now we can do that addition before the rest of the multiplication or our other subtraction because we are going left to right. 162 minus 72 is going to be 90, and 90 plus 8 is 98. And I think that's what the calculator told you, yes? If you don't feel confident on your order of operation steps, that's fine. Just stick it in the calculator, let it do it for you. Because it can be confusing and it's easy to get some of the steps for order of operation mixed up. If people didn't get confused with order of operation, there wouldn't be as means or questions posed on the internet as there are. Questions on this here? Let's do one more. Negative 2 times 4 to the fourth plus 6 times 4 cubed minus 3 times 4 plus 11. There it is. At this point here, I just take the calculator. Negative 2 times 4 to the fourth plus 6 times 4 to the third minus 3 times 4 plus 11. And then it is negative 129. Now you can type it in either calculator, the graphing calculator, or the 30xs, the yellow calculator. If I'm just doing straight evaluating, I might, or a lot of times I will use the yellow calculator over the graphing calculator. Because there's some of the stuff we find it easier, faster to type in that one than the graphing calculator. Graphing calculator can do it just fine, but whichever one you find it easier or quicker to type it in, type it in. Especially when we start dealing with fractions, that yellow calculator can do fractions way faster than the graphing one. Questions on evaluating? We feel good with evaluating. In behavior is the last thing we're talking about today. And really what in behavior is it's telling us or letting us know what the function or how the function is going to behave as we increase to the left and to the right. As we plug bigger and bigger values of x into the function, and as we plug smaller and smaller values of x into the function, it's going to behave in one of these four ways. Even degree functions, as we go to the left and right, are either going to open both up, the y values are going to go up, the ends of the function are both going to go up, or they're both going to go down. So if the degree is even and the leading coefficient's positive, the two endpoints or the two ends of the function are going to go up. As f of x approaches infinity, x approaches negative infinity. As f of x approaches infinity, x approaches positive infinity. As the values of x go left and right, the two ends are going to go up. Same is true with even degree negative. They're both going to go down. So f of x approaches negative infinity, going down, as x approaches negative infinity. And f of x approaches negative infinity as x approaches negative infinity. All I'm saying is the two ends are going down. If the degree is odd, they're going to go in opposite directions. Either one side's going up, the other side's going down, or vice versa. And that's really what the top two are saying. Now, it does seem like there's a lot going on here, but it gives us, one, an idea. If we understand in behavior and how the graph should look, it tells us what we should expect to find. So, we have all this here. So let's look at this first one here. Describe the end behavior of the graph f of x equals negative 0.5x to the fourth plus 2.5x squared plus x minus 1. So the two main things I need are the degree and leading coefficient. So what is the degree of this here? 4. What's our leading coefficient? Negative 0.5. Now the degree for this here is even. And the leading coefficient is negative, yes? So now what I'm going to do is I'm going to go back to our four charts and find even and negative. Now this here is our answer. Even and negative tells us f of x approaches negative infinity as x approaches negative infinity. And f of x approaches negative infinity as x approaches positive infinity. And that's the answer. That's the description of the end behavior. Really what this end behavior is telling me, that since the degree is even and the leading coefficient is negative, we should expect both of the endpoints, or the graph, to go down towards the negative side of the y-axis as we increase to the left and to the right, away from the y-axis. We understand what that's doing, yes? So again, this isn't going to be something that's hugely critical, but it's something for us to pay attention to. Now, when I look at the graph, I should expect the graph to go down, to approach down. Now, for this here, I already graphed this one here. I graphed it right here. Now, as I go to the left, as we increase or decrease to the left, we see that it goes up and then it goes down, yes? That is what we expected to do. As we increase to the right, we see that it goes up and then goes down. They are, as x approaches negative infinity, the f of x, the function itself, is going to negative infinity. It does agree with that. As x approaches infinity, the function itself is going to negative infinity, yes? Now, when we talked about graphing in chapter 2 or chapter 3, we looked for the values of x that made the function equal 0. We looked for where it crossed the x-axis, yes? We see that it crosses at 4 places, and the end behavior is going down in both spots, yes? So is it likely for a 0 to show up outside of this window? No, because the function is going in the end behavior direction we expect it to do. It's not going to miraculously go back up because the end behavior says that it should stay going down, yes? Now, if we said that the leading coefficient was positive, well, we know that it's supposed to open up, yes? That means, looking at this window, that somewhere to the left and to the right of this screen, that function should come back up. That means there has to be zeros outside of what this window is showing us. It gives us an idea of the zeros, and it gives us an idea of what we should be looking for. Does that make sense? That's what this is going to be used for. It's more of a tool for us to see what kind of zeros we should have, what kind of values we should be expecting. Questions on this so far? Now, the overall answer, this is all it's asking for. Let's look at this next function here, negative 0.3x cubed plus 1.7x squared minus 4x plus 6. What would the degree of this be? 3, what's our leading coefficient? Negative 0.3. Now our degree for this is odd, and our leading coefficient is negative. So if I want to describe end behavior, we're looking over at our odd and negative one, which tells us f of x approaches positive infinity as x approaches negative infinity, and f of x approaches negative infinity as x approaches positive infinity. Or really, I'm expecting the function to look something like this here. As we go to the left, it should be going up. As we go to the right, it should be going down. That's really all that's saying in words. Questions on this here? Be ready for the next one. Degree and leading coefficient. What's our degree? 3. Leading coefficient. 0.25. So for us here, the degree is odd, and the leading coefficient is positive. So again, I'd flip back and see positive and odd would tell me that f of x approaches negative infinity as x approaches negative infinity, and f of x approaches positive infinity as x approaches positive infinity. Questions on this here? That's it. 3 through 6. Determine if the following function is a polynomial function. If it is a polynomial function, write it in standard form, states degree, type, and leading coefficient. If it's not, say not a polynomial. 9 through 14, well, 9 and 10 is error detection. Really, for 9 and 10, what they're asking, or they asked the students to do, was to determine if the function is a polynomial function, and then say degree, type, and leading coefficient, and write it in standard form. Both of those, there is an error. You just need to identify the error and fix it. Then 11 through 14, evaluate the given polynomial function for the given value. So figure out what its value is for that given value of x. And then 17 through 19, describe the end behavior. And that's it.